Welcome everybody. It's my great pleasure to introduce today John Odin from the Mozilla Foundation. I met John Odin last week at the ICSE 2013 conference in San Francisco. He gave a great talk on release engineering. Actually, it was not a talk, it was a keynote speech for the first ever release engineering track at the conference. I thought it was really an inspirational talk full of details, like technical stories and management perspectives. And please welcome John Odin to Google.
At Mozilla, obviously, as you can imagine, we care a lot about browsers. So this is a diagram that I put up just to show, as an organization, Mozilla is very, very small. So I wanted to note just the kind of scale what we're dealing with here. And I realize I am the Mozilla person in the Google, so I am the outnumbered person here. These are logos of these four companies. These are the four major browser companies. These are done to scale by the number of employees who work there. Microsoft is 97,000, almost 98,000 people. Google is 54,000 if you include the Motorola situation. Apple is 50, and Mozilla is 700. So that kind of, and obviously, of course, headcount, you can play, all sorts of weird statistical games here, but headcount, I include everybody, down to janitor, front door. There's different products that we work on internally at Mozilla. There's different products you work on. But just, I wanted to get the point across that the scale is very, very different here. And I'd also make this logo a little bit big so you could see it. Otherwise, you wouldn't see it at all. The other thing was, while I picked headcount, the same sort of scale mismatch happens if you talk money. I mean, we make millions per year. You guys make billions with a B per year. So it's not, right? This is not, as a startup, who you would rationally choose to compete against, right? Despite all that, we're actually holding our own. Depending on how you count it, and everyone in the world has their own version of numbers, we're between 20 to 30% of the browser market. In some locales, we're over 50%. That's not bad, considering you can hardly see our logo there on the screen. So some of that is because of the release engineering changes that we made. Some of that, a lot of it, is because of community and other things that are going on. But I want to talk about specifically how Mozilla and release engineering worked here. Hence the talk that I gave as the keynote. The idea that release engineering can be an enabler or a force multiplier for an engineering section or an engineering organization. It's not the way most people tend to think of it, so I wanted to put that idea out there. I also want to note that Mozilla is my first time. I've been doing release engineering for a long time. This is my first time in an open source environment. So some of the stuff I've covered is things that I've learned along the years. This is not NDA anything. First time ever I can publicly talk about what I do. And so that's kind of cool. And there's nothing specific to open source here. This is, as part of the general intro, this is what we have done. This may or may not work for you. You may already be doing something like this. You may spot huge holes in our logic and you say, do this, it'll be much better. Anyway, let me know what you think. And the last disclaimer I feel I have to give, because every other time I see people talking about release engineering, it's usually as part of a sales pitch that says, and therefore you should buy our stuff. I note that I'm not selling you anything. Okay. So, Force Multiplier, those of you who've ever been in the military or know anything about board games or anything like that, I went and looked up, the military have a department for this. This is the official definition. It's a capability when added to or employed by a combat force significantly increases the combat potential of that force and thus enhances the probability of success. So it's a force enabler. Right? And they have a few different buckets or categories or headings that they put this under. It can be the technology, right? If you've got a bunch of people with machine guns versus a bunch of people with pistols, that's one. If you have like tactics, like surprise ambushes or behind lines tactics, you can also have better infrastructure. So you could have all the best weapons in the world, but if you can't get bullets delivered to you, once you use up what you've got, you're sitting there twiddling your thumbs. So infrastructure, technology, and tactics are what they put a lot of attention to in the military. So I thought I'd talk about why we do that here and what we did. So we started with a couple of things, and I wanted to just up front make a couple of assertions or assumptions. The first one, release engineering is not actually covered in, as far as I know, any computer science course. I've got a degree, a master's in computer science. I've never, ever heard of release engineering until I was in my third or fourth job. And it kind of seems to be true across the board. So given that, and given that people don't really talk about what they do and they don't really trade stories, why would anyone get into this field, firstly? And then secondly, it's rarely considered to be glamorous, right? It's usually where you get caught in the ignored or you're in the hot seat, depending. Those are your kind of binary situations you spend your life in. So why would you choose this? I would want to note that actually, as a developer, I found there's different motivations for why people want to do this. So the first one I found carefully interesting was release engineers are not the same as developers. And what I mean by that is they could have computer science and programming backgrounds, but what motivates them is different. And so what I thought of as a short way of describing this, I think developers like to build a product, but release engineers like to build a pipeline or a delivery system. They don't actually particularly care too much what goes through that pipeline, so long as it's efficient and smooth. So that's a different mindset. So you want to think about that when you're hiring. That has a side effect. Your company depends on that pipeline. You could have the best software in the world. If you can't get that out to your customers, it's not worth anything. So the efficiency of that pipeline in terms of delivering out the door is what's going to be important to your entire organization. So that's why you want people who think about efficiency of pipeline. And what do I mean by efficiency of pipeline? Well, here's a couple of quick metrics just to give you some sort of concept, to see if you feel like you're in the right room. These are numbers I put together for Mozilla. I've been at Mozilla since 2007. And so some basic kind of metrics to see if we're actually making things better or worse. One of the things I measured was from the time that we have an emergency, or what we call a chem spill release. Somebody comes in the door and says, hey, we've got this problem. If you do this, 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 you can compromise the browser and you can exploit some users' data. And at a minute past midnight, we have verified it. 2 minutes past midnight, we have a one-line fix in hand. 3 minutes past midnight, we check in that fix and we declare victory. How long did it take us to actually ship that out the door and have users get bills signed, updated through QA, through to web dev, posted on sites, updates available, and users actually seeing that? It was about 4 to 6 weeks. It averaged. Sometimes we were faster than that, sometimes worse. Now we're pretty consistent. We're getting it down to, the last one was 10 hours, 42 minutes. We beat you guys slightly. And we think we can get another few hours off this still. How long does it take to ship a new feature release? That's where we put in together some new, not a one-line security fix, but actually adding some new functionality, roll it through a bunch of alpha, aurora, beta test cycles out the door to users. Used to be totally unpredictable, 12 to 18 months, could run longer, could be less. You really had no idea. Now, 6 weeks on the clock. About 10 days ago, we put out another one. It's pretty routine. It's kind of boring, actually, which is kind of nice. The other one, how many active code lines of development do we have? So we used to have 1.5 lines, so it was the main line, and then we kind of half supported the previous line or the official release line that users had. Now we have 42, which is not actually because of the book. It's just the number of people we've had ask for branches. And we support all of these on par with each other. I'll explain about that later. And the other question comes up a lot as a simple way to measure is how many check-ins can you get per day? And this is a very kind of pointy-haired boss kind of metric about how effective are developers. You know, like a one-line check-in could be, you know, a one-line fix, or it could be a total refactor that was still one check-in but took months of an entire team. So it's kind of bogus, but it's kind of useful. We averaged about 15 check-ins a day at Mozilla. Our peak is 325 a day. We do between 280 and 300 routinely. We don't even think about it. Anytime we go over 325, or actually when we go over 320, I sit up and go, ooh, look, we broke another record. So that's some sort of measure of infrastructure improvement. And that's, to me, and also a measure of how our infrastructure has improved, which means it's how our pipeline for delivering software to users has improved. So those numbers I just talked to, got us to this. This is what it looks like by market share scale, those same logos. Let me do that again. The observant ones will notice actually Google didn't change. It seemed like a good kind of milestone to place things around. Now, of course, the marketplace is still super competitive. You're still competing with 3 very large, well-funded companies. So now we just have to get features out and compete. But we have a chance. Force multiplier. So, I also want to start quickly by saying, these are a couple of steps I'm going to enumerate through, but I would like to note a hat tip to Guy Kawasaki, anyone who've seen his talks. He does have this great idea, which I like. So up here you'll see 1 of 11. This is how we are going through it. If this is totally boring to you, at least you know when it's going to end. So you have some idea of how much longer. And I promised I'll be done in 45 minutes or less if I can, but ask questions as we go along. And if it's interesting, that's even better. You know. So first off, people. As engineers, we tend to try and see a problem and try to jump in and start writing code. And instead, I actually said, let's try and switch the situation around. Release engineering used to be the highest attrition burnout operation at Mozilla. Your average lifespan was 6 to 9 months. That's changed now. We've got one of the highest retentions at all in the entire org. So I wanted to start off by going and talking to the people who cared around the entire company. Instead of writing code, I wanted to talk to people. So, first question, who are your customers? I actually felt that the customers I cared about the most, the customers I cared about the most were actually the people who cared about the survival of the organization. So founders, all the C-level executives, VP of engineering. These are people who care across individual projects. They care about the entire organization. That's a different perspective. I went and asked every one of them, not, what do you think release engineering should do better? Because they'll always say, I want faster builds. Wrong answer. Wrong question. What keeps you awake at night? If you had a magic wand, what would you fix? And I would deliberately ask those as open-ended questions, and I would deliberately sit there in silence with a notepad and a pencil and wait. And when you start poking, sometimes you have to poke them a few times to get them to answer this, but you actually start getting very different answers to the kind of things you would normally get. I'll come to those in a second. And don't forget, at some point, you should also walk around and talk with developers and QA. These are the people who are actually living the frontline battle. What do they need? You're trying to make their lives better. A voice from the ceiling? Keep going, okay. So keep an eye on the developers, but do ask these guys. My main thing was I didn't want to start building something only to find out that I had built something that really wasn't solving the problem, the real global scale problem, not just a local project problem. So they all talked about company-threatening problems. Examples, falling out, bad press coverage from shipping a bad release. If you ship a broken version of the browser that suddenly exposes a security hole, that's a lot of bad press. That's bad news. You're going to start ticking off your existing loyal users. You're going to start having new people say, oh, I don't want to use Firefox because, look, they just had this whole bunch of negative press coverage. That kind of stuff can be hard to fix. You can start losing existing loyal users. It's going to be harder to gain new users. This worries CEOs a lot. Slow response to a security problem. That's another one. How quickly can you get a security fix out the door? You actually get good press coverage out of being the first person to actually nail a fix after Black Hat or DEF CON. You have this weird market effect. If you are always consistently fast on closing things down, as soon as they become known, bad guys say, hey, it's not as profitable. I have to put all this effort into figuring out an exploit. Those Mozilla guys closed it down in 11 hours. IE, however, still hasn't fixed it 2 quarters later. Let me keep looking for more exploits there. You become a less attractive target for all the work. It's a market economy there too, you know. Losing customers because of buggy software. People complain, hey, my Firefox keeps crashing. Oh, I switched to this other browser and it works great. Bing. You'll never get them to come back. This is one of my favorite, and I used this as an example in the keynote, and I never expected to give it here. Missing a release schedule. When you have feature wars and you're actually on level footing with another browser and you're competing against them and you're on feature war games, missing a schedule is a bad, bad scene. So my example here is in June 2010, Mozilla, Google, and Opera all stood up on stage at Google I/O and talked about WebM as a new feature that was coming up. June 2010. September 2010, Chrome shipped with WebM support in a release product. 3 months later. Nice. Good job. March 2011, 6 months later, Mozilla shipped. We didn't really change the code. We'd got it working back before September. We had no way to get it out the door. We had no valid release that was stable enough to ship that we could put WebM onto. The WebM guys at Mozilla were not very happy. Neither were all the C-level folks. We have this other thing, which I'm sure maybe you guys do too, where you can actually pay to have a customized version of Firefox made. So you might have your own home pages, different set of bookmarks, that kind of thing. We call it a partner repack. People pay money both for that and also for the ongoing support, security fixes and things like that. This was so intrusive to the little bit of human time that was available in release engineering that we had to actually stop doing this in 2007. Nothing upsets a CEO more when he's trying to raise revenue than having to turn away customers with cash in hand. And question, hey, we're going to be hiring a whole bunch of developers. Will our system stay up if we double our staff? What they didn't care about, not one of them said any of these terms, which is the stuff that every release engineer really cares about. No one said anything about Agile, Scrum, Jenkins, Buildbot, Cruise Control, DevOps, RelEng. It's just like, fix these problems. I don't care how. Occasionally you'll find someone who does, but it's pretty rare. The way I phrased this earlier was, they care about the company, not the tools you use to solve company-threatening problems. So, talk to your customers. Keep doing it. Again and again, I make sure, even if it's just like, I'll walk you to the coffee machine and back, what's on your mind? Do it every few months. Business needs change. Market demographics change. What they said 3 months ago may not be still true. Not because they're whimsical, but because the market has changed. And focus on company-threatening problems. That's the global optimization versus local optimization. What else? So that was the first one. Second one was people, communications. Having actually talked to them, don't just disappear. That's another classic. It's like, I've got a lot I need to know, and I'm going behind the curtain, and you won't hear from me for 6 months. Bad news. So they don't expect miracles. They do expect you to fix things and keep them informed on what you're doing. So what I would find myself doing was finding things to measure. KPI, those of you who've done MBAs, short, succinct summaries of what you think the problem is that you're trying to solve and an easy way to measure it. Choose carefully. I'll come back to this in a second. And then Show progress, lots of progress. Consistently show something. Even if it's a little bit every day, show something. It's going to take a while to fix. It's easy to lose perspective, and most importantly, it helps you and your group keep perspective on what's going on. And keep it simple. By simple, I mean not just simple for you to explain, simple enough that someone else can explain it to someone else while you're not there. If they can both understand it, you've won. That's a good tactic. That's a good thing to measure. And as soon as you can do this, you start seeing other groups realize how they can help. And I'll come to this in a second. That's really important. Once other groups saw that they could help, that made a big, big difference. The perception had been it was all in release engineering. Here's a quick sample. That go to build thing I told you about earlier with the emergency release in the 4 to 6 weeks, the perception was in the company that all of that time was spent at release engineering. The rest of the company could just stand by helplessly and watch the flaying that was happening. When I actually went and measured the first one, which is a few releases after I got there, because the first few were totally chaotic, the actual mechanics turned out to be different. Less than 50% of the time was spent in real engine. In fact, it was a little bit over 35% of the time. The rest of the time was spent on things like back and forth with developers, QA, cross-group communication, updating websites, preparing caches on servers to handle the load, totally outside of release engineering. And these other groups, none of them realized they were on the critical path. So we found a few things that we had to work on there. The other thing we found was there was a lot of churn that nobody realized by miscommunication about whether or not we really had the fix or not. Like when someone says, go, and then someone else comes by 30 minutes later and says, wait, wrong thing, let me just check something, one last check. There's only a few of these you can do before people start throwing instruments around. So, and I give my disclaimer earlier, people will optimize for what you measure, so you need to be very careful here. I specifically did not ever measure developer coding time. I don't want a developer to feel pressurized into coding a bad fix just to beat the clock. I want them to actually do a good fix. I'll stand nearby, I'll get you coffee if you need it, but once you say go, I will snatch it and run. But until then, I'm going to be very quiet. And the other one is don't count open bugs, number of respins, number of releases. This is the kind of thing that I've seen in some organizations where people will actually start unintentionally, but getting pressurized by managers and start gaming the system. They'll close bugs to show that their bug count is good. But actually, they'll still continue work on the item. Like, if you've got to find any problems, don't reopen the bug, just ping me and I'll deal with it privately. Then there's suddenly 6 months later, they're very busy working on things that are not in any bugs, because all the bugs are closed, because they're trying to make the metrics look good. So if you're any kind of manager, I don't know the audience here, be careful what you measure. You'll have weird cultural impact. Another example, measuring check-ins. We didn't do any of this before, so I started graphing, and you guys can tease me about how I do this in Excel sometimes, not always. This we generate dynamically. This is our number of check-ins. Load throughout the day varies depending on developers in different time zones. This you can see here is across the month, so it shows the different days of the month. So you can clearly see the weekends here, which is a sign that developers have a life sometimes. And this is generated showing check-ins since I started, which I didn't get to even start this until 2009. We'd already made a bunch of improvements. I started tracking this once we crossed over 1,000 check-ins in a month. Now we're at 6,500. There's another way of showing the same thing. Note or disclaimer, we have grown. We now have 8 times the number of developers. And best case scenario, you'd expect to have 8 times the number of check-ins. However, I see some shaking heads out there. However, the reality is you're more likely to get less than 8 because you're going to have developers stepping on each other's toes. There's going to be more code conflicts, merge conflicts, all this kind of stuff going on. Same way if you'd like put things into a multi-core machine, you rarely get exactly the straight number. In fact, you don't. You always get a little bit less. So we would ideally love to get 8 times the number of check-ins. We actually got 21 times the number of check-ins over that same period of time. The rate of our infrastructure improving is faster than the rate we can hire. And we keep showing these numbers so people know what we're doing. We don't just say it once and then go away. This comes up a lot, again and again and again. Next thing is, where do you start? I found it really hard to figure out where to even start at the beginning. I was like, well, just, okay, that's it. You know, we can sit here and draw fancy diagrams. I'm just going to find something to fix today, so I know today I fixed something, even if it was tinily small. It made something better today. I use the phrase analysis paralysis. You're sitting there trying to figure out what's the best thing to fix first. Like, fix something, you know? So I didn't make any big proclamations. I just went and found something small to fix that day. And we changed the group ethic a little bit. It's like, don't try and draw a fancy diagram. We'll fix bigger, harder, more complex problems later. But for today, just fix anything. Something that you know you can fix today before you go home. A couple of reasons that's important. You want to actually know you're making a difference. If you feel like you're just going through the same stuff every day again and again, there's no hope inside, it'll never get better. At some point, you end up throwing a chair and leaving. But if you know you've made it just a little bit better today, and that gives you hope that tomorrow's going to be a little bit better again, and the day after that, again, now you're onto something. So this is a really, really big thing. And I know the joke here is it's a very touchy-feely thing, right? It's a very human thing. We are humans. We need motivators and demotivators. These all exist. There's lots of books on this stuff. But being optimistic is a big deal. Again, military had a very interesting comment on this. They care about battlefield morale like nobody else. It's another one of their force multipliers. So they do care about this. They'll actually go to the bother of taking you out of the front lines and bringing you back and sending you on vacation in a war. They have all the evidence to show it makes a difference. So, baby steps, be optimistic, start something. Start something now, and don't stop. Relentless baby steps is what got us through those differences I showed you there. We've been doing this for 6 years, we're still finding things to fix. Every one of them gets a little bit better. That's why I know that 11 hours is going to get knocked down under 10, at least, sometime in the next month or so. It's going down further. Cross-group coordination. I'm just conscious of time moving along. We found ourselves with an interesting problem, and this is something we did right at the beginning. It's like remember I mentioned all the go, no go, stop, go, miscommunications? Like, fine, stop this right now. Next release we do, there is only going to be one person we all agree to is the person who is allowed to say go. And if you have a problem, or you think you see something that's a problem that means we should stop the release, you go convince them to say stop. Don't come along, and which has happened, run in the door, hands waving in the sky, oh, it's all bad, you have to stop now, the bug is not really fixed. You have the release engineers turn around and kill all the 2.5 days of jobs that are running at the time to start scrubbing the decks to get ready for the rebuild, and then half an hour later have somebody else walk in and say, oh wait, that was a false alarm. How are the builds going? Like, oh, we just killed them because you told us to kill them a half an hour ago. It's a good blood pressure test. Don't do that. Instead, have somebody whose job is to actually get people to calm down, pay attention, cross-check it, try it again on a second machine. Does it still work there? Okay, now you have a real problem. So we appoint them before the release, not in the heat of the battle in the middle of the release. It's too late at that point. Now we found that this was ad hoc. Now we do it all the time, so now we have a group of people. This is their full-time job, is just do this. They make all the stop-go decisions. They understand the market, they understand the product, so they understand the trade-offs they're making. Like, hey, is this performance hit here really worth a respin? Or is it only impacts 0.5% of the user base, and so we're actually okay with just getting this other thing out that impacts 99% of people right now? And they need to be neutral. it's very hard to be objective and say, I'm the release coordinator and I say we should not do a respin. I think we should go. If your job is the person who's also operating the dials of doing the respin, everyone's going to say and believe that you say no because you don't want to do the work. So it has to be a neutral person. And if anyone comes along to us directly, we redirect them to the release coordinator. The other thing we had, very low tech, was we set up a mailing list. We used to have this around, but we never really used it for everything. So we transitioned all communication to that. So if you had any kind of handover, it went through that, what we call release drivers. And if there was any kind of mistake, back and forth, cross-group communication went through that list as well. Normal releases go through this as training for when we have to do fast releases, because everyone knows the process. It's the same process, just the timing is tighter. Just clock it through. Do the same as you always do, but just do it timing faster. And later on, it's handy. That's how I get these timestamps for the how long did it take us to do a release, is by getting the timestamps off these emails. Baby steps. These are all, right, fairly simple. Halfway there, almost, if you're counting. Having got those basics in place, I then started what I would call the draining the swamp phase. This is where you get the easy to get into a conversation about, ooh, this infrastructure is so broken. You know what? We should just leave it as is, and we should go over here and build a shiny new castle. It'll be perfect. It'll be wonderful. The rain will never leak. The doors will all align. It'll be a wonderful thing. The problem is you only have enough people in your team to barely keep this broken thing working. You don't have a second team of people to build a new thing. That's one problem. Even if you did have a second team of people to build a new thing, how do you know that they're going to build it perfectly? Is everything that's in here documented? Because it's not in my world. This here is a total can of worms that nobody knows where anything goes into or where it comes out of, and you won't know if you're building a new thing that actually matches the functionality of this old thing. That's too much risk. I mean, how do I know that if I make this thing happen, this shiny new thing, and there's a bug in it, will it somehow do something that's company threatening, like send the wrong updates to the wrong users because I miscalculated on something? So make sure you think carefully about this. It's very tempting to build something new. I actually found, in our case, it was better and more efficient for us to start now with something that we could do right now and start fixing our own world. So this is what I call draining the swamp. We had no end of suggestions of what to fix. People would come along with the most esoteric things that they were worried about. My favorite was the automated signing. When we generated a build, we had to go and sign them, right? Signing keys and things like that. An automated secure signing server is a non-trivial project. And everyone, a queue of people lined up at my door with that as their, you should start with that. And I was like, can I start with checking for enough disk space? Really humdrum, but actually when builds blow up in the middle of the night because it ran out of disk space, that's very, very bad news. So let's fix the simple stuff first. And again, fix something. Doesn't have to be the biggest thing, but make a difference. One thing we got, actually, to go back, the VP of Engineering at the time agreed, after some thumb wrestling, that we could have the day after a release interrupt-free. We were constantly interrupted. But the day after a release, we were off limits. If anyone had to come to us, they had to go through him. This guaranteed us to have fresh memory. I asked for this because we had fresh memory of what we'd just been through, and we needed just a day to fix something before we went back to the churn. And this was what got us out of the situation in the beginning. Once we started getting a few things fixed, then we actually didn't need this anymore. But it took a couple of years. And we would focus on what we thought was the best. What could we deal with today? The disk space thing doesn't sound like much, but it would save you a half a day of repairing a broken build halfway through. So, anything you can do to make it more robust. And mindset is expect surprises. Every time we fix one problem, we'd find another problem that was been lurking underneath. And I've lost track of the amount of times that we'd said, like, hey, how did this ever work? And that's a common thing we'd hear. And so just expect that, okay? And document as you go, because who knows what's going on here. And, It does mean every release is better. That's important in terms of giving hope. Very important. Hope, optimism. Reminder. One thing the other thing that was nice about this is that as you started to fix a lot of these smaller things, you started to have a little bit more time. Now you're one day off, interrupts to go fix things. You could actually focus on slightly bigger things. And then slightly bigger things. A couple of months later, you're focusing on things that span a couple of days. A couple of years later, you can work on multi-week projects. So this is actually a big deal. Okay, the other thing we did was a structural change, in how our infrastructure worked. We used to build continuously. Mozilla built a Tinderbox server back in '98, I think it was. And that was continuous integration. And it was building continuously, literally meaning it would finish a build, it would start a pull tip and start another build, finish the build, pull tip, start another build. It was just, even if nothing changed, it was always building, which was better than nothing, right? This is what it would kind of look like as a display page. It sorts everything by time, and basically every one of these columns is a different type of job. So there would be a column for, I had to make them small so they would fit, but there's a column for like Linux 32 builds, there's a column for Linux 32 debug builds, and this is actually 6 screens wide by the time you start adding support for all the different platforms and build types. We changed that to only build if somebody does a check-in. Don't bother building if there's no check-ins. It sounds trivial, but actually a lot of time was wasted trying to figure out which of these last 3 builds had this intermittent problem, only to discover that 2 of those 3 builds didn't even have a check-in in them. And the QA people are like, whoa, what's going on here? So if you don't even need to build, don't. Less confusing for regression hunting. Note, we're also doing build and test per check-in. And this is a little excessive. Right now, we're doing 7.3 compute days of builds and tests across Linux, Mac, Windows, 32 and 64, Android, and boot to Gecko, or Firefox OS. We do that per check-in, and we get one of those check-ins approximately every 4.6 minutes. A little excessive, so we're trying to get better about what do we need, what tests do we not need to run when, but that's our current output point. And we had to arrange these in a way that actually made it easy for people to see what was going on. So one of the people outside of release engineering designed this. This actually, as a different layout, would show the person who did the check-in, and my apologies to the folks on the screen, you probably can't read this at all. The name of the person who did the check-in, the change sets. In this particular case, he's merging a whole bunch of changes from one branch to another. So here's all of the change sets. Here's the original bug authors. Here's the bug numbers. The description of the check-in comment. And then over here, each row is a different operating system. So you've got your Fedora debug builds. You've got your OS X 10.6 opt builds, all the way down. It barely fits on a screen, but it does fit on one screen. And the color coding and the lettering is really important. So like B is for build. The numbering of here, M1, 2, 3. So Moki Test is the name of one of our overall test suites. It was too big, so we broke up Moki Test into 1, 2, 3, 4, 5, and all these all within brackets. You can re-trigger them. You can mark them with an asterisk if there's a known issue where you, as the developer who checked it in, say, oh, that's actually a known problem. Don't worry about it. I've got it. All of that's doable from here. So a developer can immediately see, did they or did they not cause a problem? That was really hard back here because of all the timing of all of these starting and stopping at different times. You could really not tell what was going on. And so therefore, you could really not tell if your change had broken it, or was it any of the other 5 people who were also in the same check-in as you. So build on check-in was a big deal, both in terms of morale for the developers, because now there was less infighting, and also in terms of clearly knowing what was going on. This helped a lot in terms of improving how many check-ins people could do per day. The other one was pools of machines. In 2007, we had 86 machines. They're all very, very handcrafted, custom, unique machines. Most of them actually were unreproducible, which is its own level of fear. And if any one of them died for any reason, which is likely when you have 86 old machines, that's a tree closing event. No more check-ins allowed. When will Relange have that Windows Opt builder back online? And you can bet the phone will keep ringing. So this is a problem. Instead of having just the one machine, what if we had another machine that was identical, that could take over when the first one fails? So we tried to start building up pools of machines. So we'd say, here's a pool of machines that can do any type of Windows build, opt or debug, and we'll have multiples. If one machine dies, others can take over, but they keep going. We're currently running at over 3,500 of these. We grow and shrink this as we need to. There's about 70% of these are physical, 30% virtual. And it depends on, we'll grow and shrink these depending on the actual check-ins that are happening during the time of day. If you remember that chart, bar charts I showed you with the load going up and down? And they're all identical. We use Puppet and Nagios on these things. You can't keep track of what's going on. This number of machines, you can't even remember the names of them, right? So never mind if they're up or down. So we use Nagios for telling us. We use Puppet for setting them up. If you have to touch one of these by hand as part of setup, it's a fail case. So we don't go there. This is a very simplistic diagram I put together. We're in 3 Amazon regions, and although I couldn't get it to fit in here, we have 4 different colos, physical colos. And this is all inside of VPCs because we don't want bad people touching our build machines, because that would be bad. Some quick gratuitous machine photos. I'll skip through here. You guys probably have way more racks than we do, but it's plausible, right? So here we have some 1U These ones do this is what we use for Linux and Windows building. This is our unfortunate OS X situation, where you have to basically build on Mac and test on Mac. So we actually put a bunch of Mac Minis racked out. So we have 4 Mac Minis will fit on a 1U shelf. And you can then put the power supplies in between, like here. The newer Mac Minis I prefer because they have a power supply built in, so you have more space, makes it easier. This is what a pallet of Mac Minis looks like if you order them in units of pallets. This always causes the IT desktop guys just conniptions. They're like, hey, I bought a Mac Mini. Wait a minute, what's this? The other thing we do is we tried testing on emulators for Android testing, and we found more bugs with the emulators than we actually found with the actual product. It was super, super disruptive. So we instead focused on doing testing on actual circuit boards. So these boards here are NVIDIA Tegra 250 boards. They run Android 2.2. And they're wired in by Ethernet, which you can barely see back here, into switches. And that's how we do all of our Android 2.2 testing. The problem with these things, they're not, you're dumping the file system and rewriting the file system continuously throughout the day. So at some point you corrupt the file system, that turns into a Nagios alert, that turns into us filing a ticket with the IT support guys. We'll pull out that machine from this custom-made non-fabric, non-metallic fabric shoe rack that you can buy in Bed Bath & Beyond for about 30 bucks. And these things I like because you can fit a lot of these into a small room, which is where we have them. So we have a few hundred of these, and you can easily pull the board out. To reset a Tegra specifically, you have a sequence of rocker switch buttons. You've got to press in exactly the right sequence. It's a 2-press, 1-press, 2-press thing. So you can't automate that in any way. It's super painful. If I had a magic wand, that's one thing I'd love to fix. However, this gets us very, very stable Android 2.2 testing. And we've been using this. We love it. And resetting and reflashing one of these things took a while to get the process down. But now when one of these crashes, it takes about 15 to 30 seconds to actually reset it and put it back in production. It spends more time walking down to the corridor to the room that has the machines in it. This is how we do our Android 4 testing. These are Panda boards. Panda boards running Android 4 have a nice feature, which is you don't need to press any buttons on them. That gives you a whole bunch of goodness, because now you can put it in a box, put the lid on it. This is a 4U box that holds 11 Panda boards, and a whole bunch of little sockets at the back. And we can run that also, driving tests. So this is how we do our Android 4 testing. And because you don't need any human intervention, you put the lid on the box and we fill up. As you can see, there's some more racks of these. That's our machines. Those are some quick machine photos. This is a big thing for us. Statistically, you're now guaranteed to have machines die every day. But we notice it. Sorry. We notice it, but the developers don't. Trees stay open. That means we can actually fix these machines in a timely, quiet manner. We don't have to be fretting about it. We can fix them right. If a machine dies and can't be repaired, it's okay. Toss it, plug in another one, image it up, have it go in and start taking up load. Build it and they will come. Multi-branch. Moving along a little bit here. Project branches. Mozilla used to be a one-track operation, right? Developers would do their check-in on one line, and then at some point we'd branch off and make a release, and there was very, very few check-ins went on that release line. It was emergency-only stuff. Problem, of course, is someone makes a mistake, checks in some bad code, stops all development. Then you get a lot of attention. That's kind of obvious if it's easily seen to be that, but if it's a whole pile of people made changes just right in a row and you're not sure who made that change, who made the mistake, it can be hard to debug that out. Meanwhile, the entire development organization is looking really grumpy because they can't do check-ins. So that's a problem. So we went first to project branches, which is something that a few developers were interested in, but most thought was just like, why you bother? The basic motivation is here now is if you make a mistake, you block everyone on this side, they're still grumpy, but you have people on other branches who can proceed along just fine. This may be all self-evident and true to everyone, but it wasn't at the time. It's still not great. You still don't want this, but it's better than it was before. But it only works if, this only works if all of these builds and tests can be handled by the same identical set of machinery. So you don't have a Windows 32 build machine for this branch that's different to a Windows 32 machine for this branch. It's only because all of these are queued up to go through the same pool of machines and to guarantee to get the same identical results that you can actually have people trust on project branches. So that was a big plus. We're now running with 42 project branches, as I mentioned earlier. They all go to the same pool of machines, and we can add more if people want it. A handy side effect of project branches is release trains. We were able to build up another 4 branches, call them special sounding names to humans like Aurora Beta Release. They're just project branches. And now we can coordinate things landing onto those. This is how we transitioned over from the 12 to 18 months long ship it when it's ready cycle to the ship every 6 weeks cadence. The way I described this to some of my customers was your release is as predictable as your flakiest or riskiest project. If you've got 3 projects coming down that's going to go out in this release and 2 of them are rock solid and 1 of them is all over the place, guess which one's going to derail your schedule? And the theory is that you might be able to back one out near the end, but the reality is when you try and do this, it typically actually causes other breakages because people have started checking things in on top of that. And so when you say, oh, project 3 has gone off the rails, let's drop project 3 out and we'll just ship with project 1 and 2, as soon as you start backing out all the code changes for project 3 that have been there for months, you're going to find 1 and 2 break in some weird and wonderful way because they had an accidental dependency they didn't know about. Now you're stuck. Your only choice is to basically get project 3 to somehow be working and slip the release. So your release schedule is as predictable as your riskiest project. Bad news. Project branches. Healthy projects ship on schedule. Late and risky projects bump them off. They don't get to land. They stay on the project branch and they wait till the next release. schedules like this are actually great for the company. Remember, the company is your customer. This is how we do it here. You can be working on a project branch. You've got to go through a sign-off process here. Assuming you got your sign-off process, you're allowed to land into here. This is our main line, Mozilla Central. And then following a cadence, if there's no problems, you're allowed onto the Aurora or the Alpha train, and eventually onto beta, and eventually out to release. All this plumbing was actually done as part of standing up our first few project branches. We then had to fill out the rest of the project branches, and then we had to go through a large culture change in the organization about this. But it's working quite well for us. The other thing okay, time running out here. The other thing was, there's some problems that, now what we've just talked about there is fairly stock standard release engineering stuff. These are all things that release engineers who've been around the board before have done and dealt with and seen. Big impact. There's a couple of other things we came across that actually are not typical, but actually were tools to problems that we had. We had tools to problems that were actually not something that people knew to even ask for. So here's two quick examples. One is updates. Remember I was talking earlier about users complaining about being on buggy software. Turns out that a lot of the people who were complaining about being on buggy software were actually on an old release. The thing they were complaining about, the crash or whatever, had already been fixed in a later release. They just hadn't updated. Okay, that seems easy, but actually the problem is we didn't make updates available. So we turned on a bunch more infrastructure at this point, and part of the idea is here is now every day we would make updates available whenever we put out a release. So if a new release comes out on a Tuesday, like happened last week, there will always be a check for updates option in the menu will always work. And that check for updates option will always get you to the latest version. We used to have people go and download the installer. A lot of people wouldn't bother doing that. Or if they did, why would you go through click, click, next, next, next? This is terrible. So making sure that they can always download an update is a big deal. Make it simple. And the other thing is be safe. You can change the update rate. So when you make updates available on our update server, we could say, oh, don't make it available to everybody. Make it just available to the people who do manual check, but don't make it available yet to the people who are just on idle timer checking. So we have people who, if you haven't used your machine for a few hours, you're not surfing, you're actually using it as a browser, it'll ping in idle time back once every 12 or 24 hours and say, hey, is there an update? We could tell those, which are the vast majority of users, not to bother. Don't do it just yet. We want to see if there's any more crash reports, if there's any problems. We do this a lot, specifically on release days. We'll throttle out just a little bit. And we're also very, very concerned about things like Patch Tuesdays, which is Microsoft Patch Tuesdays, or anytime Adobe Flash puts out another update to their plugin. It's bad news if you have Patch Tuesday and Adobe Flash update. That's when you're like, ooh, hold on, do we have to all go at the same time? Like, we'll find new problems. That's you. It's okay. And the other thing is we make it one click or less. And this is a personal soapbox. Last time I had to update Adobe Flash, it was 11 clicks, including downloading the installer and unchecking a did I want some bloatware and all this kind of stuff. So it is a one check. It's here. Are you ready? Yes, no. Do you want it? Yes, no. And this is a company policy thing. We actually have an option to turn off that and just do it, which is what Google does as well. You know, you just like, here you go. Here's your update, Chrome. In fact, you don't get a choice. That's the way it is. This is a company policy. Mozilla feels that people should have a choice in the matter. And so we choose to let people have the one click, but it is only one click. This is our live data. I just pulled this very late last night. This shows our user base. You can see we have 58% of our users are on the release that we put out on Tuesday. And we actually had it throttled down for a bit over the weekend because we weren't sure what was going on with a particular video driver. The next big batch here at 15% is the previously. This is Firefox 21, this is Firefox 20. And you can see all the rest. These are all 2%. There's this one back here is 3.6, is 3.5% or something like that. But most of our users are on the latest version. So we don't get many complaints from users about buggy software for bugs we've already fixed. We also would do things like go find some of these old clumps of users and specifically target them with specific updates. So we prompt them without having to prompt the people who are on the more recent versions and upset them because they feel like, oh, like I'm getting prompted too much. No, no, no. We'll just target the people who are way, way, way back. So update fatigue is a big thing. The other thing we put some time into was download size. We want to take care of the fact that a lot of our users are outside of the US, not necessarily on high broadband. So if you're in a developing country and you've got pretty bad internet connection, you care about not downloading a huge download. So here, this partial update is we diff literally every file. We take n-1 and n-1 being the last install and n is the current install, and we will go through and recursively diff every file. Say this file, these 7 bytes changed. This file, same. This file, these first 20 bytes. And we'll make that partial diff, which is really, really small. And you would actually be okay downloading it off of a MiFi when you're on Caltrain, which is my definition of third world, or when you are somewhere else in the third world. Pay attention to making it easy for your users. This helps you get this kind of profile. The other thing was localization. Mozilla, since day one, has always had that all locales ship at the same time and that they're all on the same change set. It's actually kind of cool. It's my first time ever working in an organization that did that. Up to now, I've always worked in companies where it's like, oh, the tier 1 most profitable countries. Then it's, oh, the tier 2 kind of profitable, but there's a contract involved. Then there's the tier 3, maybe if we feel good about it, And actually, like, all humans are equal. So we actually ship all locales, same change set, same day. This means it's harder to set up, but it's actually easier to ship security fixes. So if we need to ship a security fix at very short notice, we can do it for all locales because every locale in every operating system is off the same change set. We do that by having nightly builds so localization people can see what's going on, make changes. As active development is happening, localizers are doing active localization. That's always been true. The problem was they never got updates. They'd download a build and install it, and then a couple of weeks later, they'd remember go back and download another build and then look for differences. So we turned on infrastructure to actually generate L to N updates for those nightly builds. That made it quick and easy to find localization problems. And also, it was a big motivator for localizers. Because you can make a change, and you could see it the next day in your next nightly build. That is a massive, massive motivator. Numbers, May 2007, we had 34 locales. May 2013, we're 94 locales. This is our breakdown globally. 43%, this is ENUS. Then we get into, let's see, this is German. I have to stick these numbers on my hand. This is German, French, Spanish, Spain, and Russian, and Portuguese, Brazilian. And of interest here, I note that of the 43% here that's ENUS, about half of these, we did this analysis a while ago, about half of these are actually on IP addresses that are outside the US. These are people who live in non-English speaking countries who don't even know that there is a browser available in their language. So they download the American one. So we're working on that. But this is a problem that we had tools to fix that nobody knew to ask. That's why those leading questions, the open-ended questions at the beginning were so important. So that's it. Companies live or die by that efficiency. How efficient can release engineers make an organization? Well, I've just gone through some of the things we did. And the way I like to put it, this is what release engineering looks like at Mozilla. If this group of people can make that kind of a difference, what could you do?